There are many discoveries that have been made in the field of astronomy recently. One of the most important and most interesting of these discoveries is the finding of phosphine gas on planet Venus. This was such a profound discovery because it gave scientists the possibility that there may be life on Venus, but it is a lot more complicated than just that. The study of rocky planet atmospheres can give us clues about these planets' surfaces and subsurfaces, so this is clearly an area of interest for astronomers and their studies. Additionally, finding information about planets outside of our solar system is very difficult, but these inner solar system planets can give us clues as to what planets are like much further away. It was only the unexpected result of an experiment when phosphine gas was found, and this baffled scientists. This discovery is seen as so important because scientists could not identify any abiotic factors that could have produced this gas. Now, the production of phosphine is known to occur in certain extreme environments. For one, it occurs in the depths of the gas giants Jupiter and Saturn under extreme temperatures and pressures, where it is brought up by the process of convection. However, this molecule is otherwise only made naturally by life on planet Earth in extremely oxidized environments. This meant that the phosphine on Venus was a huge mystery. The initial goal of the experiment was to find anomalies in the chemical signatures of Venus's atmosphere. Scientists began their search by exploiting the phosphine 1 to 0 millimeter waveband. This is a signature waveband of phosphine that is able to absorb against even the thickest clouds of Venus's atmosphere. However, scientists were not attempting to detect any phosphine in the atmosphere. They were merely setting a benchmark for future developments in the experiment. Finding phosphine was basically an accident. Detection of this molecule was verified by the collaboration of two different telescopes and their varying technologies. Both the GCMT and the ALMA showed the same results for the presence of phosphine in Venus's atmosphere. This was especially crucial because it meant that the detection of phosphine was not merely an error. The results were consistent under varied and independent processing methods, where there were no other molecules detected besides phosphine under the selected signature wavelength. There were exhaustive studies on the chemistry of Venus and how light could have interacted with chemicals to cause the presence of phosphine, yet this discovery remains unexplained. There are no currently known production routes in Venus's atmosphere, clouds, surface, or subsurface, and there is no evidence of the phosphine coming from lightning, volcanic activity, or meteor impacts on the planet. Now this begs the question, why is this discovery so important? And, well, there are a few ways that this question can be answered. For one, this discovery was important because it was so extremely unexpected. Scientists have either concluded that there is much about the rocky planets that we have yet to understand, or that the chemical process which occurred to make phosphine on Venus was so complicated and obscure that it could have been the result of living organisms in the clouds. One particularly interesting aspect of the discovery of phosphine in Venus's atmosphere is the fact that it was found near the equator and not near the poles. Scientists have suggested that this is because this area of the atmosphere offers more temperate altitudes, as the poles of Venus contain polar caps, which are less suitable for microbe survival. Thus, one theory alludes to the idea that phosphine was only found near the equator because this would have been the most ideal environment for the reproduction of microbes, again pointing to evidence that the presence of phosphine was a result of life on Venus. Now, scientists have thought that there was a slim possibility for life to exist in Venus's clouds for quite some time, even decades, despite all glaring difficulties that microbes would face. For instance, microbes would face almost immediate destruction from sulfuric acid. However, for now, the fact that life could exist on Venus at all remains an extremely important prospect, and whether or not microbes can exist in the clouds of this planet is a prospect that has not yet been ruled out.